the vacuum of space. We imagine it as a sterile void, a place of absolute cold, absolute silence, and absolute emptiness. But if you could travel 4,000 parsecs from Earth, if you could stand on a dust grain floating in the chaos of the galactic center, and if you could take a deep breath without perishing in the vacuum, you would notice something impossible. The universe, in that specific corner of the dark, smells distinctly like rum, and it tastes like raspberries. How do we know this? We cannot bottle the air of a nebula. We cannot send astronauts to taste the interstellar medium. To touch the stars, we must read the ghost messages they send us. We use the science of spectroscopy. Every element and molecule in the universe has a unique fingerprint, a specific frequency at which it vibrates, rotates, and interacts with light. When complex molecules rotate in the cold depths of space, they emit radio waves. By capturing these waves with massive radio telescopes, we can decipher the chemical barcode of the cosmos. We don't need to be there to know what is there. We simply need to listen to the chemistry. Our journey takes us 25,000 light-years from home, to a region known as Sagittarius B2. This is a giant molecular cloud, a cosmic nursery. It possesses a mass 3 million times that of our Sun. It is here, in this chaotic laboratory, that astronomers from the Max Planck Institute in IRM turned their telescopes, searching for the holy grail of astrochemistry, amino acids, the building blocks of life. They did not find the amino acids they sought. Instead, sifting through thousands of spectral signals, they found a match for a complex ester called ethyl formate. On Earth, ethyl formate is a volatile ester. It is the chemical dominant in the flavor profile of raspberries. It is also a key component responsible for the smell of rum. In the vast, dark clouds of Sagittarius B2, there is enough alcohol and raspberry essence to fill 4 trillion pints. However, we must temper our romanticism with astrophysical reality. If you were to travel to Sagittarius B2, you would not find a floating orchard or a galactic pub. The density of these clouds is lower than the best vacuum chamber on Earth. The particles are microscopic dust grains coated in ice. And alongside the raspberry molecule, astronomers also detected propyl cyanide, a lethal poison. The universe is not cooking for our pleasure. It is cooking because chemistry is a universal constant. The resulting cocktail would not be delicious. It would be toxic, freezing, and fatal. But the presence of the molecule matters more than the experience of it. The discovery of ethyl formate leads us to a profound realization about the origins of life. We used to believe that complex organic molecules, the COMs, could only be forged in the favorable conditions of a planet. But Sagittarius B2 proves that the universe is a factory for complex matter. It synthesizes long carbon chains in the freezing void, long before stars or planets are even born. These molecules are the seeds. If the precursors to life, the flavors, the structures, the chemistry, are created in the dust clouds between the stars, then the ingredients for life are not rare. They are ubiquitous. They are everywhere, waiting for a wet, warm rock to land on. We look at the night sky and see light. But a radio telescope looks at the sky and tastes raspberries. We are not separate from this cosmic chemistry. The atoms in our bodies, and the molecules that allow us to savor the sweetness of fruit, were born in the same clouds that drift between the stars. The universe is vast and dark, but it is not flavorless.